y equals 1 over x minus 1. Let's have a look at this one then. The area of interest where the curve just changes values rapidly is around when x is 1, isn't it? Just above 1 and just below 1, because the denominator will be 0 then, won't it? So if we look at those points of interest, so when x is 1, it's undefined, isn't it? So let's mark that off first of all then. Now just above 1, if we put 1.1 in here in our mind's eye, you can see that 1.1 take 1 is 0.1 and 1 over 0.1 is 10. So at 1.1 it's 10. And if we put 1.01 in here in our mind's eye, that will be 0.01. 1 over 0.01 is 100. So I hope you can see that the closer and closer that you get to 1 from above, this value will get very, very large. So here, as x tends to 1 from above, y tends to shoots off to infinity. So we've got an asymptote here. So let's draw our line for an asymptote then. Oh, the 1's fitted in rather well there, hasn't it? So I'll put the 1 just to the left. Okay, so it shoots off to infinity here. So it's going to shoot up to infinity just above 1. Now just below 1, if we put 0.99 say in here, or 0.9, we'll get minus 0.1. 1 over minus 0.1 is minus 10. If we put 0.99 in, we'll get minus 0.01. 1 over minus 0.01 is minus 100. So it shoots, the closer and closer it gets to 1 from below, it shoots to minus infinity, doesn't it? So, and as x tends to 1 from below, y tends to minus infinity, wasn't it? And we verified that by looking at the points around just under 1 and just above 1. Okay, we've got that. The other point of interest with these sorts of curves then is when x gets large, because here if we put in say 1000, we'll have 1 over 999, which is really, really small but positive. So again, as this goes along here, it's going to be just above 0, isn't it? So it's going to tend to 0. If you put say 1,000,000 in here, you'll have 1 over a really, really small number and it'll be really close to the 0 line, but just above it. So I hope we can start to see what's happening here. So also, as x tends to infinity, y tends to 0 from above, so put a little plus there, and as x tends to minus infinity then, let's look at minus 100. We get minus 1 over, we get minus 101. 1 over minus 101 is very, very small, but it's negative, isn't it? And if you put in a minus 1000 here, you'll get an even smaller negative number. So we approach 0, but from the negative side. So we can mark that down, that observation down as well. There's no other turning points in these sorts of curves. And we could differentiate to verify that if we wished. But so this is what's going to happen then. The only other thing of marginal interest is when x is 0, because it goes through the y-axis. So we could note that as well. At x equals to 0, y is equal to then. Put 0 in here. 1 over minus 1 is just minus 1. So we could mark off minus 1. So what happens then? Let's just try and draw this sketch with a digital pen then, as best we can. So what have we got then? We've got coming down here, and then shooting off to infinity there. We've got it coming up from minus infinity through minus 1, and then tending to 0 there. And this we can label the sketch y equals 1 over, oops, I don't know what happened there. Let's just do it again. Y equals 1 over x minus 1. And there's the plot. Let's just verify that. Quick sketch on our plotter tool. A little widget tool here. 1 divided by more than one term, put a bracket x minus 1. From minus 10 to 10 say. Let's do that. Have a look at the plot here. And exactly what we expected. It goes through minus 1 here. If the graph, this plot had been generated for more y values, then it would have continued to get closer and closer to this asymptote here, wouldn't it? So that's fine.